Hello, everybody. Oh. Hello, everybody. All right. I've been doing a million of these live streams. So right now, I'm basically, this is probably one of the last ones, I swear. But basically, and I'm doing this more for like reference. I know not a lot of people tune into these because they're not very big yet, but more so for reference. So I figured, here, let's go check. I promised everybody that I would show you guys a demonstration of the Launchpad. What the heck is this? So I'm gonna do that right now. So I have a video that I recorded. Actually, it looks like it's still got about a minute left. Yeah, so come back to that. But I did record a video of a full demonstration of the Launchpad, which is gonna be pretty cool. But anyway, this live stream is basically going to be to finish up some CAD work, 3D print some stuff, and you can see, like I know I already explained the whole pad system, but basically these two guys right here, they have a bunch of wires coming off, going through the pad to the computer back here, and then also all of these servos and the launch tower do as well. So all of that has to get routed to the launch computer, which it already has been, but those wires all need covered. So just in case, any exhaust gases do somehow make it into the launch pad and not all the way out of the flame trench, I want to make sure that those wires are nice and protected so I don't have to do unnecessary work. But yeah, so let's open up the slicer as well, and that way I can get that work done. How much time do we have left on processing? We are super close, guys, with this video upload. So I will show you as soon as it's uploaded. It's like 2 minutes out. So to create a new project here, I'm actually going to change the nozzle out. So we will go to the device, change the printer part, 0.4, and then what I'm going to do. Oh, by the way, video is done, so let's go check that out. I promised everybody, so here we go. Here is the demonstration. Oops, what the heck? All right, so here's the demonstration of the pad. All right, I'm going to describe how Aurora's new Launchpad Borealis works here. This is version 1.1, and we'll start off with the switches here. This is the main switch for the onboard pad computer, and this is the pyro switch. There are several onboard pyro channels. Only one is being used in this scenario, but this is for the onboard ignition, so I don't have to wire up a launch controller to the pad separately. Over here you can see the interface. The interface is basically what controls all functions of the launch pad. Starts the countdown clock. You can adjust the countdown itself, reset the entire system. All that's done through this interface. And there's also a speaker here for the audible countdown. I move over here. There is the clampdown system. Basically, it holds the rocket down, as you can see, until certain time that I've set in the code, so it can hold it down for as long as I want while it's under thrust, or as little as I want before launching. Then we can move up to the launch tower here. The launch tower has a servo actuated claw release, and as you can see, it also has an LED indicator
on each side, indicating or blinking in sync with the countdown that is shown on the interface. The claws release right before ignition, around 3 seconds. You can also see the 2 angled exits on the launch pad. That's basically the flame trench, so that'll divert the flames out the pad without damaging any equipment. Then we move to the rocket itself. The rocket has an onboard IMU, which is used to record data, send that data to the thrust vectoring mount, angle the thrust vector mount, and correct the rocket. All of the data that is recorded and then sent to the TVC mount is also recorded on the onboard SD card / data logging system. Up here, you can't see because it's in the back, is the parachute system. There is a spring-loaded parachute bay door that is actuated by a servo and deploys the parachute system. So now what we're going to do is we're going to basically demonstrate how this whole system works. So I've already taken off the remove before flight tags, but there's one that goes right here like this that I take off, and there's also one that hangs on the rocket's avionics bay door like that. So what I'm going to do, I'm going to boot up the main computer on the launch pad. You can see it's going through its boot up sequence. Okay, the pad is now active. You can see the time, the default time of 10 seconds is displayed on the interface, and I can adjust that time, add or subtract from it however I want. In this case, we'll do 15 seconds. Then I'll come over here and I'm going to open the safety cover on the power channel, but not enable it yet. Then I'm going to come over to the rocket. Battery is plugged in. Now what I'm going to do is I'm going to enable the rocket itself. Okay, so you can now hear the rocket is enabled. What I'm going to do is now I'm going to enable the pyro channel on the computer. So everything is enabled. And in this case, since I don't have an igniter, I have a motor in the back here, which will basically do the same thing, fire for the same amount of time that the igniter would before releasing the clamps, just as a demonstration. Now we are going to start the countdown on the interface. You can see as the time goes down, there's also audible and visual indication that the rocket is counting down. At 3 seconds, the claws open. The motor will fire, and the clamps will release. The rocket is now thrust vectoring, and then a few seconds after that, the recovery system deploys. You can also see that after the rocket leaves the pad, the support claws eventually close. And now, if I want to reset the pad, I simply come over here, press the reset button. All servos return to the home position, and the countdown returns to the default countdown time of 10 seconds. And you can see the rocket is thrust vector. So that is essentially how the new Aurora system works. And we are going to be launching in a few days, so hopefully everything goes well.
Alright guys, so there you go. There's the demonstration that I promised. Hopefully you learned a few things from that and were interested. But yeah, so we're going to do some CAD work here. First, I'm actually going to print a file that I have already CADed but needs reprinted. So let's look for, actually, you know what? I'm starting to think oh, no. It may not be under here. I will look and see. But we're basically looking for, there's a little plastic piece that goes in that T connector right there. You can kind of see. And it goes on the PVC pipe just to protect the pipe from being completely obliterated. So we're going to look through all this crap. Let's see, switch it. Nope, that's not it. Tower, nope. right. Follow-away strut, Launchpad wood. You know, starting to see. Let's take the T connector and let's. Oh, there it is, right here. All right, I'm actually gonna increase the size of this sucker. So let's do like, how much did I have earlier? Let's do like 0.75 on either one. I think, or maybe, maybe let's even do 1. I think it's gonna handle it fine. There, like that. And then we can export the piece. Boom, piece exported, opening it in our slicer. Bada boom. And what we're going to do is we are going to change the material. So we are not going to do PLA in this case. I'm actually going to do generic PETG. So, boom. All right. Then we're going to turn on support. Boom. Slice the plate. This should take, let's see, 15 minutes, so pretty short overall. So what I'm going to do is I'm going to change out the nozzle really fast, put the new nozzle on, and then start the print on the printer. So in the meantime, what we can do is we can start adding the other part of it, which is going to be probably the ASA cover, and what else is I thinking? Oh, I'm also going to print a wire protector / lead for the ignition leads, so that should be interesting. All right, so what we're going to do is we're going to cut the filament. Boom, filament's coming out. Pull off the heat sock. Then I'm going to take a screwdriver and very gently I'm going to pry open the holding switch. Done. Okay. Switch or holding clamp is off. I can take out my nozzle. All right, so I essentially had a 0.2 nozzle in there. I'm taking it out now. And let's see, 0.2 nozzles out. By the way, anyone watching, if you're interested in seeing how the pad works, I played a video earlier demonstrating how the full system works. You can scroll back and watch it. Right now I'm changing out a 3D printer nozzle on a Bamboo A1 Mini. And we're going to start printing a relatively simple file here once I get this all hooked up. And we're very close. It's very, very simple process to change out a nozzle. So, all right, I already got the nozzle on. Now we're going to stick the filament that I want to use. Yep, Bamboo is absolutely awesome.
I love bamboo. Alright, so I have just changed out my filament from PLA. Now I'm going to run over and grab my PET sheet. We're going to throw this sucker in the dehydrator. For some reason, the Elegoo is not booting up anymore. I'm not really sure what the heck that's about. Alright, filament's loaded. Alright, print. Oh, I had the A1 selected for some reason. A1 Mini 0.4. We're going to use supports. Interesting. Slice. Print. Send. Alright. Alright, so now I'm printing my file. What I'm going to do now, and actually you guys can probably see on the camera, but look, let's see. That's a way to get a camera since my computer camera won't work. Just go through my printer camera. Hello everybody! 2 frames per hour. No, I'm just kidding. All seriousness, this thing is a freaking beast. I love this machine. It's fast. It gets prototypes, parts out like insanely fast. I do like the LED strip, which is generously given to me. Alright, so yeah, let's go back and CAD some stuff. So basically, this is what I was thinking. You guys can see over here. Oh, and I never even updated the logo. So we're going to do that first. But basically, this little piece here goes inside the Launchpad. Basically right by, like, pretend you're looking at the front of the Launchpad. The control interface would be right here. And it's going to take all the wires, feed them through this channel across to the computer. But I actually don't know. I'm thinking that this might need to be stuck on the other side. So let's see where the sketch starts. I'm going to modify that. Boy, this might be a bit of a challenge. So sketch 3 maybe, 5, 6, 7. Where does it actually? Oh, whatever. All right, I'm just gonna delete this first because this is not my logo anymore. So we're just, and this is like, these are all very basic shapes, nothing fancy. So we're going to delete this, and then we are going to go and take my logo off of the other piece. Where the heck is the 2S? My gosh. There, finally. Basically what I'm going to do now, copy my new logo onto the flame protectant wiring case. And we're going to scroll all the way over here. Should say ASA switch, yep. Sketch 7 or 6. No, it was 7, wasn't it? What the heck was it? 7. That wasn't it. Yep, it was 7. Alright, we're going to copy that onto here. Boom, there's my logo. Logos are cool.
done. Actually, looks like it's like all selected. So here, transform. We're gonna move here, scale it down, and we're gonna pop the logo right here. Okay, and we'll go down a little bit more. Okay, that actually doesn't look too bad. So I'm gonna figure out a way to modify this. It's been a while. I've CAD'd this way back in January. We're gonna move this to the other side. I think that's a better idea because that way I'm not risking the fact that this might interfere with the whole mechanism, or the clampdown mechanism and the flame trench. So we're gonna move it. And I just booted up the Elegoo. Alright, so let's figure out this thing first. I want to see actually if I can print it on the A1 Mini because I feel like that's my best bet. Here, oops, here to here is 7 inches. So probably not, unless I did it upright, then I could. If I'm being totally honest, I think this channel should probably be separated because that would make installation a tiny bit easier. So let's see, here to here, 7 inches. So this whole thing is about 9 or so inches across. Which is basically the entire inside of the pad, so that's good. And now I want to see, I might actually give this a rest and CAD the, CAD the wire protector for the ignition leads, because I feel like that's like a 2-second job. But you know what, we'll do it anyway. So let's start with sketch 1. Let's see how I did this. So this is probably a really stupid way. So it looks like I started off by making a channel like that. Then for my next move, I made that channel. So what I'm actually going to do is I think I'm going to delete, or you know, let's just suppress extrusion 2 for now. You can always unsuppress it. So yeah, there you go. Basically, I want to move sketch 2 to be further down. So like sketch right here, sketch 7, extrude 2, and sketch 2. And then I want to select sketch 2 to instead be not where it's at, whatever. Gosh darn it. So let's just look at sketch 2. What is the dimensions? Got 0.25 inches coming out from there, and it is 1.25 deep. So I say I'm just gonna do it right here. So we're gonna do, what did I say? 0. So let's do 0.5. And how far across is the channel itself? It's 1.75, so we're just going to go 1.75 inches that way. Then we're going to go like this. And then we'll do You know what? Let's do this. 0.25, 0.25, and one more time, we'll go 0.25. Then what I'm going to do is fill the inside like this. Boom. Now I'm going to extrude that out, however many inches I did it earlier, but we'll just start with that. Then what I'm going to go is I'm going to go to extrusion to itself. See the inch that I did. So once press. I did 7.24 inches. So I'm going to delete that now. 7.24. Delete. 7.24. So this guy needs to be 7.24 inches. 7.24 inches. And then what I'm going to do is we're going to extrude this face to be filled in, so up to here. Merge with all. Done. That is now filled in. I'm going to move my logo out of the way. And then, okay, so that's good. We're gonna chamfer the outside and then fillet the inside. So here, we're gonna chamfer these edges. So I feel like that would look cool. Doesn't really matter for that. And then we're gonna fillet all the areas that we need to be kind of structurally sound. So we'll go these corners, the outside corner, and then right there, like that. And then let's increase until I don't like it anymore. So 0.25 will do. 0.24, 3, 0.22, 0.21. Fine. Alright, 0.2 inches. And we're going to select this face, extrude, remove, blind, through all, merge with all. Sketch 7, we're going to delete this, delete this, delete this, and we're going to delete this. Alright, and a bunch of other stuff. And then I'm going to move that up to here. That did not work very well. No, didn't want it there. Why would I ever choose it to be there? Alright, so here's what we're going to do. Move this guy up. This is a really stupid way of doing this. Alright. Please. Oh. Nope. That's bad. I really should have just started this over, but I'm being super lazy right now. Anyway, so that guy is good. Now let's do some fillets on the inside here. I like fillets because they actually do make a huge difference in terms of structural integrity. So yeah, and then let's go to sketch 7. We're gonna move this guy, and he's gonna be dead center now. Let's do a 0.025. Alright, and then I'm actually going to lower, let's go lower and maybe to the left a bit more. So yeah, this is actually a much quicker live stream than I was going to expect. So let's go. Let's go like there. Okay. Oh, looks like I forgot about the exterior fillets. So let's just do fillets everywhere. I think fillets are cool. All right. And then let's make that also a fillet to be consistent. And then done. All right, so that's kind of good. I think I'm gonna keep that where it's at. Now let's CAD the last part I'm looking for today. So first, let's go to the Launchpad. Let's double check our diameter of the inside of, actually this is two. Clamp assembly. Let's go back to the clamp assembly and let's double check that diameter. .756. So let's do 2.656. And then, so let's see, 2.656. All right, I'm going to type that number in so I don't forget it. 2.656. Now let's make a rectangle. We're going to make that rectangle, let's do 0.75, and then height, let's do like, gosh, how much is the 1.55, looks like. So, not that big. All right, so now what I'm going to do is we're going to extrude this out, probably just like 1/4 of an inch. And then I'm going to make another reference sketch on this plane. And I'm going to make it a distance out from here, some arbitrary distance right now, so we'll just do that. And then what I'm going to do is set my diameter to be 2.656, which is what we determined earlier. And then now I'm going to bring this guy in, not that much, like that. Or shoot, I meant to do that the other way. So it would be, no, yeah, that's right. So what we're going to do is actually I'm going to bring that down. So like, let's do 1 or 1.1, like that. And this is basically going to touch the back, or touch the wall of the clamp mechanism, I guess, if that makes sense. And let's actually go like this. Let's go like that, and then like that. And then that way I can extrude just this portion. And then we're going to select, nope, not that, just this face, if it lets me. I don't want it to do the whole thing. Shoot. Actually, there's a better way of doing this. Hold on. I was being stupid. Let's actually reference this guy on the what am I doing? Let's make the sketch on this actual plane, and then that way I can make the radius what I want it to be. So let's do a 3-point arc, and then let's go from midpoint to midpoint, and then let's make this, what would that be, 2-point? I don't think that's gonna work. Nope, we don't want that midpoint. Let's do less than that. Let's go up from the bottom, like meter. Let's start that. Let's do. Okay, that's good. All right, now let's do this. Boom, boom. Then we're gonna go boom, boom, remove. There, so now we have a slightly curved rectangle. Ta-da! And then now what I'm gonna do is we're gonna make it match in color to our other part. Now what I'm gonna do is we're just gonna make another sketch on here, and I'm gonna make 2 little channels for the igniters. So let's do point 2 and 0.2 from the midpoint on the side. Oh, what the? Never actually even fed any filament through. Hold on, printer went berserk. I don't know what the heck just happened. Alright, let's see. Let's go down. Let's go down to the edge of that guy, like that. We'll make it like 2 millimeters wide on both of these. Oh, shoot. Not mean to do that. This is also like a really stupid part. This is really like all the important stuff I did not on a live stream so I could focus. But yeah, this is like kind of stupid. So let's go from like midpoint to midpoint, midpoint to midpoint, and then like that. Let's remove. Oh, actually, let's go back. And this is just to make sure that I'm going all the way through. This is like the crappiest possible way I could CAD something, but again, I don't really care. This is a really useless part, so boom, boom. All right, channels are good. I'm gonna fill it the inside of those guys just a tiny bit. All right, that's probably good. Then that will get glued on the inside. And hopefully my printer does what it's supposed to do. And we can also open Elegoo and get that sucker running, so being efficient. But yep. Alright, so that's CADed. And this is CADed. I'm trying to think what else. Oh, yeah, so I'm going to do also a couple of channels. So let's insert the one channel so I can show you, like, yeah, this is what this looks like. Yeah, there's a lot of these parts are like really bare bones, but some of them are complicated. Interface cover took me like a while. This guy. So 90, we're gonna go 90 this way. Oh, and then this way. And then let's go from the top. Stick it in here. Come on. So there, that's what I'm talking about. So you guys can see now, right here inside the pad is that cover that I just CADed, and all of the wires coming off from the interface and the switches get protected in here, then routed directly back to the computer. But that's not all of the wiring on the pad. We also have, and that's why I left a little bit of a gap right here, is I'm going to make a channel that goes from this guy, routes to the side, goes back, and then all four of these servos, they have to get routed directly to the computer as well. And all of it's wired, but it all needs protected. So I'm going to wait until I print the first cover just to make sure everything works. And then we're going to then we're going to CAD that other piece. So what I'll do is this little, let's see. Oh, another thing, this guy needs bolts. So we're going to add the bolts to here. Oh, that's not what I meant. Standard content, I used, what did I use, 632? Yes. So we're going to go standard bolts, machine screws. We're going to go with 632, and I believe they were 1 inch. So, and then we want, no, that's not right. It was not. It was a hex, wasn't it? I think it was. Yeah. Alright, so let's do, nope. Shoot. Socket head? There we go, socket head. 632, 1 inch. Alright, insert. We're gonna insert another one. Insert. This isn't really necessary, but I'm just doing it anyway. Let's see. Mate connectors. We're gonna hide all mate connectors. And then now that looks good. Let's take this assembly, and hopefully it's gonna let me move it without there being a problem. It's probably not. Nope, it's not. Forgot. Gotta select this guy, and then where the frick is the servo? Alright, there we go. We're going to want these guys as well, even though they're mate connected. Also want to make sure that everything moves. So it should move. Let's see. Oh, God. Why is the servo doing this? Shouldn't be doing that. When I clicked on the folder, everything should have selected and it didn't, but whatever. Now we're going to move it back an inch. Alright, boom. It's been moved. Now I can insert the spacer that I CAD'd right here. Alright, we're going to move this guy. I wish I was not this boring. Alright, so this is going to get, nope, that's not what I was looking for. I wanted to move it. This is going to get moved here. I'm not even going to bother with the mate connect on this one because this is kind of a like easily removable temporary part that isn't going to be on every launch, so it's not like it kind of matters. No offense, Mr. Spacer, you are still sort of important. Maybe, not really. Alright, so see the spacer's on there. Let's move it back a little bit more, like that. Alright, so now the pad's pretty much updated. Actually, we gotta put LEDs in still, so let's do other documents, public, red LED, 5mm. Oh, look at that, ta-da! Oh, this is annoying. There we go. So let's make a folder for this. We're going to go LED 1. Now I'm going to select LED 1, and I should be able to move the whole thing. Yep. And let's do mate connector. Let's go here to here. Well, that's fantastic and all, but you didn't select everything else, so forget it. Alright, you know what? Screw it. We're just gonna wing it. Now let's copy two more. Goodness gracious. I duplicate this thing. Alright, so I duplicated LEDs. Right now, we're going to move this one to where it's supposed to be. Ah! 90. Alright, so this little guy goes right in there. Just like that. Alright, so now let's take our second LED, make a folder, oops, stop, LED 2. And then let's take this guy, LED 3. Alright, so let's take LED 2, let's move LED 2 into position. These are just regular 5mm LEDs that I used. Alright, and then let's go with LED 3. He's going to go all the way up, over, way back here, way over here. Whoa, what is happening? Alright, I guess that works too. Right. Okay, let's go up like that. Let's move this stupid thing. And then let's go right there. Rotate it. Alright. Boom. Boom. And boom. Alright, now let's go this way. I could have done a main connector, but this is way more fun. Sure, it's like semi-annoying, but it is so much fun. Alright, we're going to select LED 2, or move him back a tad just to be consistent with the others. And there you go. So that's basically what the launch tower looks like in person. It's got the LEDs like that, and they're encased like so. I'm surprised the person actually like CAD'd the whole interior of LED like that. That's crazy. So yep, that's what she looks like. CAD cover. Let's get the next part exported. Oh shoot. Alright, and then let's go over here. I'm wondering if, maybe just to be consistent, I will round this guy too. Let's think about this here. No, let's leave it. And then let's go, yeah, generic PLA. Let's see, how precise is this little guy? It's probably alright. Alright, so that file's good. Let's go home. New. Let's go to this sucker. And let's export it. Actually, let's see. Let's make it. that. Alright, let's open this file in here. Yep, it's like freaking massive. Oh, it's so close though. Holy cow. Can I like rotate it and get it to fit? That'd be freaking hilarious. Oh, it's so close. Let's see, what if, no, that wouldn't work. This is like the only way I can print it, because that's a 9. Oh yeah, height-wise, it's like not even close. Alright, so this will have to be printed on LED, which is annoying, because LED stinks. Stinky LED. I hate you. Bye-bye. Alright. Well, in the meantime, let's open this guy up. I'll print those pieces, and that's pretty much all I have for this live stream. Just something simple. Thanks for watching, everybody, and we will be launching Wednesday, so be sure to stay tuned. I'm going to hopefully, I know I always promise, but I should hopefully have a video coming out soon about all the projects. Several videos coming out about all the projects I did this summer. That was the printer. Alright, so thanks again for everyone who was watching, and